Okay, we're going to integrate using a double substitution step. Okay, here's a first example of an example we went over in class, but this is just in case you want to see it at home. When I look at this integral, I'm going to rewrite it as x times x minus 1 to the 1/2 power. All right, we know why we do that. We need to look at everything written in terms of powers. And then we take a look and we realize that the piece that we have being raised to the power is that 1/2. I can't make my life easier by distributing the x through, because you're not supposed to do that when x minus 1 is being raised to the 1/2 power. You can't. So what I'm going to do is I'm going to let my u become what's being raised to the power, x minus 1. And then the process for substitution is then we take the derivative of u. When we take the derivative of the other side, we get 1 dx, or just simply dx. And our problem we have is that we never get rid of this x. And we need to be able to write this entire integral in terms of u and du. Well, I got this part in terms of u. I have that part in terms of u, because this becomes your du according to this. I got to figure out what I can substitute in for x. Alright, so now it becomes that double substitution piece. I'm doing my substitution here, but then I'm going to do another substitution piece to figure out what x is going to become, and that's where I'm going to use this statement here. And this statement is the fact that we know that u is equal to x minus 1, because that's what we let u equal. And now what I'm going to try to do is I'm going to try to solve this for x. And I'm going to solve this for x by adding 1 to both sides. That gives me u plus 1 is equal to x. So now when I go to rewrite my integral, right, the u to the x minus 1 to the 1/2, well, that's just u to the 1/2. The dx we said was du. I can simply substitute that in for du. And now x, we can't leave that x there, so now we're going to rewrite that x as a u plus 1. Alright? And unlike this step where we couldn't distribute that x through because the binomial was being raised to a power, now we have the binomial being raised to that first power, u being raised to the 1/2. We can distribute that u through to make our life easier. So the integral, distributing the u through, we get u to the 1/2 times u to the 1. That's u. You add the exponent, so u to the 3/2 plus u to the 1/2 times 1. So I did this. Now I'm doing this. That becomes u to the 1/2 du. And now I'm ready to integrate. So this is going to become, I'm going to add 1 to the exponent, u to the 5/2. I'm going to then divide by 5/2, which means I'm going to multiply by the reciprocal, which is 2/5, plus, there's that u. I'm going to add 1 to the exponent. That makes it 3/2. I divide by 3/2, which is the same thing as multiplying by 2/3, plus c. Now I plug the u back in. Well, according to this, u was x minus 1 to the 5/2 plus 2/3 u, which is x minus 1 to the 3/2 plus c. And that is how we integrate using that double substitution step. Well, here's another problem that we have, in which it's a little bit more complicated because now I have that x squared in front, but it's done the same exact way as the last question was done. We're going to start with substituting in for x minus 1, okay? Then that means that du is going to be dx. Alright, so we're going to take care of this, and we've taken care of that in terms of substitution step. Haven't taken care of the x squared. Well, we're going to try to substitute in for the x as we did last time using this. So I have u is equal to x minus 1. By adding 1 to both sides, we get u plus 1 is equal to x. So now I'm going to get ready to rewrite this integral. There's still a lot more to do. So I rewrite the integral, and I'm going to get the u to the 1/2 piece. Okay, u to the 1/2. Then dx is du. All right, and then x, which is u plus 1, becomes u plus 1 squared. Now I can't distribute this through because that's being raised to a power. So what I'm going to do is do a little side work here. U plus 1 squared means this. And then when I FOIL this, I get u squared plus u plus 1. So that's u squared plus 2u plus 1. Alright, so I'm going to rewrite my integral now as u squared plus 2u plus 1. And then that's being multiplied by u to the 1/2 and du. Well, now can I multiply that or distribute that u to the 1/2 through? And the answer is yes. The reason why I did all that was so that I could. So when we do that, just remember as you're multiplying these things through, you're going to be adding exponents. So I have u, when I multiply this u to the 1/2 times this u squared, this is really 4 over 2, so I'm going to get 5 over 2, plus 2u, adding a half to a 1, that's going to get me 3/2, plus u to the 1/2 du. And I finally have been able to rewrite, this nasty looking integral in terms of something that I can now take care of. So this becomes, now this first time now I'm beginning to integrate. This is u. I'm going to add 1 to the exponent. That's 7/2 divided by 7/2, which is 2/7, plus 2. There's my u. I'm going to add 1 to the 5/2 divided by 5/2 means we're going to multiply by 2/5. Then plus u, add 1, I get 3/2, divide by 3/2, same thing as multiplying by 2/3, plus c. And now we're going to substitute in for u. 2/7. Well, u is all the way up here. There it is. U is equal to x minus 1. So x minus 1 to the 7/2. Plus, now what happens here is nothing's going to cancel. That's really over 1. It's going to get me 4/5 u, which is x minus 1 to the 5/2, plus 2/3 u, which is at x minus 1 to the 3/2, plus c. And we're done. I guess what I want to do right now is if you are watching this video and you're in my class, I'm going to ask this as a bonus question. What I want you to do is I want you to show that the derivative of this guy here becomes that. Okay, so if you're doing this question or you're looking how to do this question, first of all, it was a bonus. It's a bonus to for the question that looks like this that I'm asking you to do for homework. It's not exactly like this, but it is like it. But if you see this video and you want to attempt to do this derivative and show that eventually becomes this, with all the algebra that's involved, I'll give you some more bonus points if you're able to do that. All right, good luck. Have fun with that one.